Okay, today we're going to look at solving absolute value equations. We're going to look at it two different ways. One by graphing, and then also the other by just using algebraic, just doing it algebraically. Okay. It's got a little blurb up there as far as what absolute value could be used for. That's not overly important into what we're going to get into. So let's go ahead and jump to example 1. The first thing that you're going to want to do is you want to get the absolute value by itself. Okay, which if you look at the first one, kind of look up there. The first one, it is already by itself, so we're not going to have to do anything. But if you look at example 2, you've got the minus 2 after the absolute value. We'll have to move that before we graph it. Right? So, if it's already by itself, the first thing I'm going to graph is the absolute value of x minus 5. The second thing I'm going to graph is just y equals 2. Now, if it's the absolute value of x minus 5, which direction is that going to move? You just did a whole quiz over transformations. To the right 5. Okay? So I'll go over to the right 5. That's where my vertex is going to be. And then I'm going to graph it there. I'm going to have a slope of 1. You need to make sure that you graph this accurately, because whenever we find the solutions, we're going to find the solutions where the two lines intersect. Okay? The line y equals 2, is that going to be horizontal or vertical? Horizontal. Right there where y equals 2. And whenever you give your solutions, you're just giving the x values. And so what are my two answers on this one? 3 and 7. And that's it. Okay, hopefully not too difficult. But hopefully you can see the importance of graphing it accurately. Let's go to this next one. So, what is the first thing I need to do to the equation? Need to do what?
Move it to the left one.
Before that.
Reflect it across the x-axis.
Nope. What do I need to do with the minus 2? I want to move it over to the right, so I need to add 2. Okay, so I'm going to end up kind of changing the equation to get this right here. Oops, sorry. Absolute value of x plus 1. And then now I'm going to graph those two things. Okay, the absolute value of x plus 1 and 5. X plus 1 is going to move which direction? X plus 1 is going to move which direction? Left. Then I've got the line y equals 5. Once I have that graphed, Gavin, what are my two solutions on this one? Negative 6 and not 3. 4. Okay, so going down to example 2, which is the second example 2. So if I need to get this absolute value by itself, so what's the first thing I want to do? Need to do? I'm going to subtract 4. So I have negative absolute value of x minus 3 equals 1. And then how am I going to get rid of that negative? Divide by negative 1. Okay, I want you to graph those two. If you think you did it wrong after you graph it, then you probably did it right. So whenever you graph this one, x minus 3, that's going to go to the right 3. That's not right. There we go. Okay. And then now I've got y equals negative 1. So if the solutions are where they cross, and they never cross, then there's no solution. It almost makes too much sense. There we go. Okay. Now, I want to point something out on this. So, kind of put your pencils down. You don't have to write down this next stuff that I'm going to do up here. Okay. Give me just a second here. Okay. So whenever we graph these, we got it to this point right here, and this is just one of the ways you can do it by graphing. You could graph this side of the equation and then 5, and you would still get the same answer. You could graph this and then 1, and you would get the same answer. Okay? So if I was to do that, if I had, let me get a different color here. We'll go green. If I was to graph that one, so it's negative x plus 3. And then I've got the line y equals 1. Those two lines also do not cross. If I did this one, right 3, up 4, and it reflects, there's that part of the graph, there's that part of the graph roughly, and then I've got y equals 5. Okay, still don't cross. If I went up to the one above and I graphed the original one, I would have x, it would go to the left 1 down 2. And then I would have the line y equals 3. And I would get those same x values. Negative 6, positive 4. Okay? The reason why we did it the way we did it is if you were just to graph this part right here on the last example, I feel like there's more mistakes that could happen than if you were to graph this. If you do it this way, it's always the absolute value of x plus or minus a number. So you're just dealing with the left and right. It's always on the x-axis. It always has a slope of 1, and then you're just graphing a horizontal line. Okay? If you do it this way, also, anytime this number is negative, or if the line is below the x-axis, it's always going to be no solution. If it's above, then you'll get a solution. Okay? And then there's another reason why I like it, and I'll kind of explain that on the back. So, go ahead and go there. So another reason why I like us doing it that way is if you do it algebraically, the very first step, get the absolute value by itself. Okay, so if you have to do it algebraically, you got to do that anyways. Step 2, it says solve for a. If the absolute value of x equals a, then x equals a, or x equals negative a, which just is very wordy. Okay, so to kind of make sense of that, look at example 1 and kind of look up there at the screen. Let's say we don't know what's in there right now. What two values could I put in there that would give me the answer 5? Okay, don't add, just one number. But there's two different answers. Okay, 5, so the absolute value of 5 is 5, and the absolute value of what is 5? Negative 5. Okay, those are the only two numbers that I could put in there. Okay, 5 and negative 5 for that to make sense. So I need to know that, because what I'm going to do after I've got the absolute value by itself, which on the first one it's already there, I am going to set whatever is inside the absolute value bar equal to 5, and I'm going to set it equal to negative 5, and that's going to give me those two solutions. Hopefully everybody can subtract 1. I don't think this process is too difficult. On example 5, what would be the first thing I would need to do? I would need to add 6. Whoop, not 3, 15. And so now I'm going to set x plus 2 equal to what two numbers? 15 and negative 15. No, not add 3. Divide by 3. So I'm going to divide by negative 3. And now what am I going to do? Somebody tell me before you actually do it. David?
Make it equal to negative 3.
No. Somebody take a guess as to why I wouldn't do that.
Oh, this is no solution.
Why is it no solution?
Because it's going up. It's not reflecting across the x-axis, so it can't ever reach that.
Can't ever reach the negative 3. So anytime you have this where the absolute value is equal to a negative number, right there, that makes it no solution, because absolute value makes everything positive. The answer to any absolute value is positive. So you need to look for this. Don't just blindly go through the process, because the process is pretty simple, and just not pay attention to this one little part. All right, you should be looking for it, because if you get a negative, you're done with the problem. It's no solution. Okay? It does not matter. Make sure that you know what is giving me this, okay? I've got the absolute value of something equal to negative something. Okay? I don't care what's in there. That gives me no solution. I want you and your buddies next to you to work on these problems. I'll be putting the answers up there gradually as I walk around and help people out. Yes, sir.
Yeah, actually, those are 6 meters.
Somebody tell me what the answer to the bonus is. Why?